Hi everyone, and welcome to this episode of Keipert Labs. In today's video we're going to be discussing the 5 main types of chemical reactions that we come across in chemistry. We've got kind of the overview that you can see here, and I'll outline them in a second, and then we're going to go through each one in turn with an example. So we have combination or synthesis reactions, decomposition reactions, single replacement, double replacement, and then combustion. Okay, so each of the reactions that we come across, by and large, will fall into one of these types, and that through observing kind of how we would define these, that then you can start to spot them wherever we come across them. Okay, so the first one we're going to go have a look at is combination or synthesis reactions. Okay, so we're going, basically we are producing fewer or / more complex products. Okay, so we're typically going so 2 or more reactants to one product. Okay, so we might generally say things like A plus B forming AB as a general sort of label. Let's see if I can make it perhaps a little bit more visible for you. I appreciate the contrast isn't flash there. Okay, so A plus B producing AB. So some of the examples that we would come across, okay, we've got magnesium plus oxygen gas forming magnesium oxide. Okay, now this isn't balanced so far. We can see that we've got 2 oxygens here and 1 over here. So what we have, we do this in order to balance it. 2 to 1 to 2. Okay, so we have 2 reactants combining together to form one product. Okay, we could also see if we do sodium metal plus chlorine gas forming sodium chloride, that's also a synthesis or combination reaction. Okay, so it's a building up reaction. Okay, now we're going to have a look at decomposition. So the essence of the decomposition reaction is that we are breaking down a more complex reactant into simpler or a greater number of product molecules. Okay, so we might see, okay, starting off as AB, breaking into A and B as separate elements, okay, as a kind of a general sort of label. Okay, so perhaps, let's see if I can. So one example that that we might see, okay, so where you have sodium hydrogen carbonate decomposing into sodium oxide, carbon dioxide gas, and water vapor. Okay, so we've got more complex reactant breaking down into multiple simpler product molecules. Okay, we might also see it when we have our water molecules decomposing into hydrogen gas and oxygen gas. Okay, so in each of these is an example of the decomposing or breaking down. Okay, so now we're looking at single replacement. Okay, so where one element replaces another in a compound. Okay, so if we had AB plus C, that's C replacing B in this compound, would be that kind of general sort of example. Okay, so if we say had magnesium and hydrochloric acid, okay, that the magnesium replacing the hydrogen to give us magnesium chloride, and we get hydrogen gas over here. Now, one thing I'm going to start to do to show you is being able to put in states to show us what state of matter each of these substances is in these processes. Okay, so we've got little s, little g, so S for solid, G for gas, AQ is for aqueous, which means dissolved in water, and if we had liquid, we would use L. Okay, so here, so we've got one element replacing another in a compound. Okay, so that's kind of a key aspect here. All right, now we're going to have a look at double replacement. Okay, so a double replacement reaction where So where two elements in compounds swap places. Okay, that we're typically thinking about this in terms of ions in what's called a precipitation reaction. Okay, so where we're specifically forming a solid precipitate. Okay, so if we had, say, silver nitrate reacting with calcium chloride to form silver chloride and calcium nitrate. Okay, so in this case, so that the silver, so you can consider it either way, that either the nitrate and the chloride have swapped places, or that the silver and the calcium have swapped places. Okay, to form two new compounds. What happens in this case is that then the silver chloride is a solid, it doesn't dissolve in water, and so we get a white precipitate, a silver chloride. Okay, so probably the generic equation that we're looking at here would be, say, A and C swapping places. Okay, to form two new substances. Okay, and then so the final example that we're looking at here now is combustion. Okay, so we've got a compound that mainly contains carbon and hydrogen, which is a type of compound called hydrocarbon, reacts with oxygen in the air, and we form typically carbon dioxide and water. Okay, so now, so there's not really a lot of point making a generic kind of example here, because the hydrocarbons we come across, like the reaction tends to be quite specific to each one. So I'll give you a couple of examples here. So methane reacting with oxygen gas to form carbon dioxide and water. Okay, or isopropyl alcohol, reacting with oxygen to form carbon dioxide and water. So now, just looking at this in terms of balancing, we have 6 oxygens over here, plus another 4 makes 10, but we've got 1 over here, so I only need 9 oxygen atoms. So these come in pairs, so that's not really going to work for me to have 3 and 4. Okay, so what I'm going to have to do is I'm now going to have to adjust this. So I'm going to say, right, let's make 2 of these. I've got 6 carbon atoms, which means I need 6 of these. I've got 8 times 2 is 16 waters, so I need 16 hydrogen, so I need 8 water molecules over here. I now have 12 plus 8 makes 20 oxygens. I've got 2 over here, which means I need 18 here, which means I need 9 pairs. And that's my balanced chemical equation for this one. Okay, another one is this one, which is called octane, which is the main component of petrol. Okay, so I'm forming carbon dioxide and water. Okay, now, so same deal, I've got 8 carbons, 18 hydrogens means 9 water molecules, which gives me 18. Okay, now what I get here is that I get 16 oxygens here, plus 9 here makes 25, which is an odd number. Okay, so I can't make 20, I can't do that in terms of pairs here. So same problem as before, or same solution as before. If I have 2 of those, then that means that I have, what was my number? Okay, so I've got 2 lots of 8 makes 16. Okay, 2 lots of 18, so it's 36. So it's 18 there. And then that means I've got 32 plus 18 makes 50. So 25 oxygens there. Okay, so each of these is an example of a combustion reaction. So a hydrocarbon, which is mostly carbon and hydrogen. It can include other elements like oxygen or nitrogen as well, but predominantly carbon and hydrogen in some form, reacting with oxygen in the air, and we're typically forming carbon dioxide and water. The only way that we would form something different over here is that if we don't quite have enough oxygen. What we get then is what we call incomplete combustion, which is something we go into in the HSC course, but I'll just illustrate it a little bit for you. Okay, so if we take methane and we don't have a sufficient supply of oxygen gas, then what we end up doing is we end up forming carbon monoxide and water. And if we have even less, if we actually stretch your understanding just that little bit further and say I've actually only got half of the right amount of oxygen gas, then I actually end up forming soot and water. Okay, now based on the fact that this is probably making you uncomfortable to do this, I'll do it like this to change it to be this, so that the proportion is still the same, but we're not now talking about half molecules. Now the reality is that we can't have half a molecule, but as you'll see in our next unit, if we start considering these in terms of moles, that half a mole is reasonable. Okay, so we've looked at the 5 different types of chemical reactions we come across: combination or synthesis, decomposition, single replacement, double replacement, and combustion. Hopefully you will have noticed by now that the synthesis and decomposition reactions are kind of the reverse of one another, that generally speaking that they work in opposite ways. Okay, thanks very much for watching. Bye for now.